Hello, scholars, and welcome to our very first homework video. I'm super excited about this. I'm very passionate about homework videos because I really believe it really helps students. It can really take students from 2 grade levels below to 1 grade level above or on grade level. It could also take students that are on grade level to passing state tests with a really high average. So I hope you learn to appreciate it, and I hope we do a lot of our homework. All right, let's get started. So as I said before, you want to practice all of your problems by yourself first. And then when you watch this video, you want to work through the notes with me. I'll try to be not too slow, but also not too fast. Let's get started. It says multiply 23 times 35. So I'm going to show you two methods how I multiply. The first is standard algorithm. Okay, so in standard algorithm, you want to place both factors on top of each other. 23 times 35. Then you want to start with the ones place and then go to the tens place. So the 5 is going to be multiplied by the 3, and the 5 is going to be multiplied by the 2. 5 times 3 is 15. Carry the 1, bring down the 5. 5 times 2 is 10 plus 1, which is 11. Now we can't put 11 in one place value, so that 1 goes in the 100s place, and it goes just like that. Now we're working on the tens place. Because we're working in the tens place, you want to place hold the 10. And we're going to add at the end. So the 3 is going to be multiplied by the 2, and then the 3 is going to be multiplied. The 3 is going to be multiplied by the 3, and then the 3 is going to be multiplied by the 2. 3 times 3 is 9. 3 times 2 is 6. So now you're going to have to add 115 plus 690. 5 plus 0 is 5. 1 plus 9 is 10. Carry the 1, bring down the 0. 6 plus 1 plus 1 is 9. And your answer is 905. Now we want to use another system to show our work, and that is going to be the area model. Okay, so when we're dealing with 23 times 35, that is going to be a 2 by 2 area model because there are 2 digits in 23 and then 2 digits in 35. You want to create area, and you want to separate it by its place value. Well, you want to separate it by decomposing the numbers. So in 23, you can compose 23 into 20 plus 3. And 35, you can decompose 35 into 30 plus 5. Whenever we multiply, we want to look at the digits first. So we're going to multiply 3 times 2, and that's 6. Then you want to ask yourself, how many placeholders are there? 1, 2. Then you just bring down those placeholders, which helps you understand that 3 times 2 is 6, but 30 times 20 is 600. Then you want to do the same thing here. 2 times 5 is 10. How many placeholders are in 20 times 5? 1. So you want to bring that placeholder down. Then you want to go here. 3 times 30, so you want to multiply this, and then you want to multiply this. 3 times 3 is 9, and you have 1 placeholder, so it's 90. 3 times 5 is 15. There are no placeholders, so it's just 15. Then you want to compose your factors. 600 plus 90 is 690, plus 100 plus 15, 115. 0 plus 5 is 5. 9 plus 1 is 10. Carry the 1, bring down the 0. 6 plus 1 6 plus 1 is 7, plus 1 is 8. Let's go back here. I did something. 6 plus 1 is 7, plus 1 is 8. If you caught that error, that's good. Silly Mr. Ray. And this is really good for checking your work. If you have enough time, you want to do your multiplication in 2 different ways to help check your work sometimes if you have the time. Now, I'm going to push you guys, I'm going to push you scholars forward to looking at this with decimals. 2.3 times 3.5. That's also written as 23 tenths, because the 3 ends in the tenths place, times 3.5, which is 35 tenths. Okay? Because this is written as fractions, you know when you multiply fractions, you multiply the top by the top and the bottom by the bottom. What do we already know? We already know that 23 times 35, as seen here, is 805. We also know that 10 times 10 is 1 times 1, which is 1, and you have 2 placeholders, which makes it 100. Now, 805 over 100 means 805 hundredths, which means that the 0 and the 100 ends in the hundredths place. I'll show you. So here you have your ones place, decimal point, tenths place, and 100ths place. The 0, the last digit in the 100ths place, which is the 5, goes in the 100ths place. Then you just build your numbers from there. So your answer is going to be 8 and 5 hundredths, because this 5 ends in the 100ths place. Okay? Some of you may do really well here, but you may struggle here. This is a really great way to start looking at multiplication in decimal form. Let's go ahead and move forward to some work that we've been working on in class. So, it says decompose. We know decompose means to break apart. The rectangle along the diagonal. So decompose this rectangle. This line symbolizes a diagonal line. And recompose, which means to bring back together the two pieces to make a different shape. So it's not going to look like this, right? It's going to look different. We're going to rearrange these two triangles to create a different shape. Then part B says, how does area of the new shape compare to the area of the original rectangle? Now, I'll give you 2 examples, and then you can give me another example. So let's just look at it so that we can make sure we're arranging our triangles correctly. When I look at my triangle, I notice that the bottom part, or the base, is 3 units. 1, 2, 3. And I notice that the height of my triangle is 2 units. Okay? So I know that when I rearrange my triangles, it needs to have a height of 2 units and needs to have a base of 3 units. So let's write down some notes. We know that we can decompose the rectangle into two small triangles. Both valuing at 1/2 the area of the full rectangle. Okay, so let's create one. I want to rearrange it where I have my height at the top. So I know my height needs to be 2 units, and I know that my base needs to be 3 units. 3, and I want to close it. I also know that my base needs to be 2 units and my height needs to be 3 units. I can do it this way. Let me try it another way. Maybe I can rearrange them so the triangles can be side by side. So I know my height can be 2 units and my base can be 3 units. And I can do the same thing, base 3 units, height 2 units, like that. So I just did 2 examples. I want you all to go ahead and give me a third example here. Remember, when I ask you to give me extra examples, you have to do it for a grade. That's how I'm going to grade this work. How does the area of this new shape compare to the area of the original rectangle? Well, I know that the base is 3 units, the height is 2 units. And I know that the base of all of my examples is 2 units and the height is 3 units. So I would say the base or grounded side is 2 units and the height, vertical side, is 3 units. It takes up same amount of space. Remember, we're finding another one here. Let's go to this problem. Let me bring this down so that you can see this better, so that it's easier, you can easily like view it. So it says the area of the square is 1 unit. Oh, so this is 1 unit. 2 small triangles can be put together to make a square, to make a medium triangle. If this is a small triangle, I know that I can make 2 small triangles. So that means my small triangle is 1/2 unit. It also says 2 small triangles can be put together or composed to make a square or a medium triangle, which means that if I had 2 small triangles, they can create a medium triangle, which also is 1 unit. two halves make a whole. Which figure also has an area of 1 1/2 square units? Now, 1 1/2 means that there is one whole unit plus 1/2 unit. It could also be decomposed to say 3/2 units. This says select all that apply. And in class, we realized that select all is not a trick. So write this down. Select all means that there is always more than two or more answers. So more than one answer, right? Always more than one answer choice. So if I only selected one answer, I know that I could not get this right because it says select all that apply. There's more than one answer given. So now I want to look at the figures. When I look at the figures, I notice a medium. I notice a small. I notice a small. I notice a square. And I notice a small. I notice a small, 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 small. I know that small triangle equals 1/2. I also know that 3 small triangles equal 1 plus 1/2, which equals 1 1/2. So I'll try 1. Here I see one small, and one small, which is 1/2 plus 1/2 plus 1/2 equals 1, 2, 3, 3/2. And when you're turning your improper fraction into a mixed number, how many groups of 2 go into 3? How many groups of the denominator go into the numerator? 2 goes into 3 one time, plus 1 over 2, which is 1 1/2, which tells me A is one answer choice. Using this information, how many more answer choices are there? Because it says select all that apply. I'm going to select figure A. You go ahead and select all that apply. Remember, it's going to be graded. The area of a rectangular playground is 78 square meters. See that I circled a number? If the length of the playground is 13 meters, what is the width? Whenever you're reading word problems, you want to create a know and find section. What do you know about what you're reading? And what are you finding? I want to push you all to challenge yourself to figure out what you're finding as as early as possible. I know that I need to find what is the width. What do I know? I know that the area is 78 square meters. I also know that the length is 13 meters. Interesting point. Here it says the area is in square meters, the length is in 1 meter. It's because area is 2 dimensions. You have a length and a width. Okay? Right? This is saying that, oh, and we know the area is the amount of cubes, the amount of cubic units inside a space, right? The amount of cubic units, the amount of square units, excuse me, that cover a space. Sorry about that. We know area is the amount of square units that cover a space. This is saying the area is 78 square meters. We know the length is 13 meters. We don't know the width. See, here I created a known and find chart. Here, I visually modeled what I'm trying to figure out. I know my length, I know my area, but I don't know my width. So let's look at formula. We know that the formula for area equals length times width. We know the area is 78 square meters. And 78 square meters equals, follow the equation, length, which is 13, times, do we know the width? No, we do not know the width. Now, how can we figure this out? What questions are we asking ourselves? We can look at it 2 ways. We could say 13 times what is 78, or 78 divided by 13 is width. Okay? That is a form of figuring out the inverse operation. The inverse is the opposite. So we want to multiply. We cannot multiply. So what we can do is we can divide. Since 13 by 13 cancels out, 78, we have to figure out 78 divided by 13. How can we figure that out? We want to divide. When we divide, we find groups of 13. So we have 13, we have 26. If you're confused, like I can be sometimes, I can just put plus 13 here. 6 plus 3 is 9. You have 39. You can add that plus another 13. 9, 10, 11, 12. 1, 2, 3, 4, 5. 52. We have 52 plus 13. You guys see what do you scholars see what I'm doing? 2 plus 3 is 5. 5 plus 1 is 6. 65. We're getting close to 78. Let's see. 65 plus 13. 5, 6, 7, 8. 6 is 1 is 7. Do I keep going or do I stop? I believe I should stop because I found 78. One group of 13 is 13. Two groups of 13 is 26. 3 is 39. 4 is 52. 5 is 65. And 6 is 78. So what is the width? The width is blank. Go ahead and write your answer. Which brings us to the final problem. It wasn't that bad, guys. I mean, scholars. I'm working on that. It wasn't that bad, family. First, we want to read the problem and highlight what information we have to help us solve the problem. A student said, we can't find the area of the shaded region because the shape has many different measurements instead of just the length and the width that we could multiply. Now, there are some factors to why the student has an understanding of area. Just like in this previous problem, we realized that an area is length times width. However, area is also the space that covers the number of squares within a region, right? So we have to ask ourselves, is this a region or plane? Yes, this is a region or plane. We also see that it is an irregular figure. However, it can be decomposed into multiple different rectangles. Do you see that? Also, it can be decomposed, and also you can shift it to see the square units. Now, what do we know? We know that area we know that area is the amount of space or or squares, the amount of squares that covers a plane or shape. So if the space is fully covered, and does not overlap, we can fill space with unit squares. Okay, so given this understanding, what do you think? Or we know that he is incorrect, right? So given this information, how do we know he is incorrect? Write that here. How do we know that this student is incorrect? Right here is where your parent will sign or beat point, and they will check off if you solved the problems in your notebooks before watching the video. Well, not the notebooks, but on the scrap paper. And also, did your student also watch the video to take the notes? If your parent signs and checks to show that you did all of the work, you will receive 2 B points. If your parent only signs, you will receive 1 B point. If your parent doesn't sign or check it off, unfortunately, you are not receiving a B point because you didn't go above and beyond. Make sure you show your work on scrap paper. If you do that, I will also administer a B point. Also, make sure your name is on your paper. If your name is not on your paper and you do not circle what cohort you're in, you don't get credit, which is a waste of a 0. If you did all that work, you want to make sure you put your name and tell me what cohort you're from. Thanks, scholars. Bye-bye.